Hi students, hope everyone is fine and safe. It gives me immense pleasure to welcome you all to my new video. And today's video is about another interesting concept in the subject analog and digital communication. We're going to see about noises. In this video, we will see what is noise, what are the different types of noises, and we will see the characteristics of noises. Before going in depth about noises, first you got to understand what is noise. Technically, we can say noises are the undesired signal which is getting added with the original message signal when you transfer the original message signal from the transmitter to the receiver, right? So noises are undesired signal. So this undesired signal is going to affect our original message signal. So what will happen? So when you want to transmit an original message signal from the transmitter, we'll use some channel. Say for example, we are going to use a wireless channel to transmit the original message signal. The receiver will receive that particular signal, right? So you will transmit a message from a transmitter through the channel, and the receiver will receive this particular signal. But the receiver not only receives the original message signal, it will also receive noise. That is, whenever we transmit any particular signal through the channel, definitely noise will get added to that particular signal, right? So the original message signal along with the noise will be received at the receiver. So if the noise is very less, then it will not affect the original message signal. If the noise is going to be very high, then it will definitely affect the original message signal, and we will not be able to detect the original message signal at the receiver, right? So it is very important that we should eliminate this type of noise, or we should have a control over this type of noise, right? So in order to recover the original message signal accurately, this noise factor, right, this has to be reduced, right? For that, the SNR must be high, signal to noise ratio, right? What is SNR? SNR tells you what is the signal power and the noise power in a particular signal, right? So how good the signal is, that is depend upon this particular SNR value, right? So if the noise is very high, then you'll have very poor SNR, and which means your message signal will get degraded. We can classify this noise as predictable and non-predictable noise. What is the predictable noise? If the noise can be predicted, we can able to remove that particular noise by proper design or by using a proper filter, right? If it becomes unpredictable, then we will have problems in removing that particular noise, right? And we have different types of noises like internal noise, external noise, man-made noise, terrestrial noise, all those things. And today we're going to see about all these noises and what are their characteristics, right? So as I said, noise is the undesired electrical signal which are added with the original message signal, right, during the transmission. And this can be predictable or unpredictable. If we say predictable, we can definitely eliminate it by proper design of the filter, right? For example, power supply hum, spurious oscillations, all those things can be removed by proper design. Whereas if it becomes undesirable, random, right, it cannot be able to control it, right? So in that case, we have to take some sort of an effort to reduce the level of that particular noise so that we can able to recover the original message signal properly at the receiving side, right? And there are two different noises, that is, we can classify it as external noise and internal noise. Noise which happens external to the receiver or the communication system are called as external noises, right? Whereas noises that is created by the components inside the communication system itself, that can be an active component or a passive component. That type of noise is called as internal noises, right? And when it comes to external noises, we can classify external noise as atmospheric noise, extraterrestrial noise, man-made noise, right? So we have different properties for each and every noises. First, you will see atmospheric noise. Atmospheric noise can be caused by due to lightning discharges and thunderstorms or other natural electrical disturbances. right? And it comes in the form of amplitude modulated impulses, and it happens random and spread over the complete RF spectrum, right? And it affects the TV as a field strength is inversely proportional to frequency, right? It morely affects the TV signals. And at 30 megahertz and above, these noises are very less. That's because higher frequency are limited to line of sight, and sources generate little noise in very high frequencies, right? So the main property of this particular noise is this will be very less if it goes above 30 megahertz, right? At frequency 30 megahertz, this noise is very less. And when it comes to extraterrestrial noise, there can be different types of extraterrestrial noise, like solar noise, cosmic noise. Solar noise, a very good example is noise from the sun, which happens at a very high temperature. That is, sun radiates broad spectrum of frequency, including spectrum for broadcasting 11-year long cycle, right? And at the peak of this cycle, electrical disturbances cause corona flames and sunspots. And similar to sun, even there can be noises arises from moon and other galaxies, right? That particular noise are called as cosmic noise. So stars also radiate noise in same way as sun. Noise from star are called as black body noise. Like Milky Way, noise also comes from distant galaxies. And these noises are significant in the frequency range from 8 megahertz to 1.5 gigahertz. In range of 20 hertz to 120 megahertz, it is stronger. That is next to man-made noise. And below 20 megahertz, it penetrates below the ionosphere. Right? These are some properties of this cosmic noise. And when it comes to man-made noise, from the name itself, you can understand it is the noise that happens because of man, right? That is man-made noise because of the inventions which we have done, the technology which we have evolved, right? The devices which we use, the noise created because of all these things are called as man-made noise. So electrical noise produced by automobile and aircraft ignition, electrical motors, switch gears, leakage from high voltage lines, etc. comes under man-made noise. And this is very intensive in industrial areas, densely populated urban and suburban areas. And noise is effective in the range of 1 megahertz to 600 megahertz, right? And coming to internal noise, this is very important. Internal noise, as I said, this can be also called as fluctuation noise. And because this happens due to spontaneous fluctuations of the system. That is, it happens because of the components present inside the system, right? And it can arise because of thermal motion of free electrons inside the resistor. That can be due to, that is called as Brownian nature, right? Brownian motion. And the random motion of electrons in vacuum tubes and random diffusion of electrons and holes in semiconductors. All this can create this internal noises, right? This fluctuation noise or internal noise can be of different types, which is short noise, thermal noise, transit time noise, and miscellaneous noise. We will see one by one. When it comes to short noise appears in active device due to random behavior of charge carriers. That is, due to random emission of electrons from cathode, this type of noise happens. And also due to the diffusion of minority carriers and random generation and recombination of electron hole pairs, this type of noises can create, right? And current in these devices, in electron devices, flows in the form of discrete pulses every time a charge carrier moves from one point to other, which creates this type of noises, right? Although the current appears to be continuous in nature, this particular phenomenon is discrete, right? And we can represent this short noise like I of t is equal to I naught plus I n of t, right? And this is this I n of t which vehicles around the mean, right? These are the properties of short noise. Whereas coming to thermal noise, from the name itself you can understand, right? It happens due to the motion of charged particles, which is related to the thermal energy, right? The noise arising due to the random motion of free charged particles, right? That is called as resistor noise or Johnson noise. The intensity of random motion is proportional to thermal energy. As I said, the motion depends upon the thermal energy, right? And it is zero at the temperature of absolute zero. And this type of noise is called as thermal noise. When it comes to transmit time noise, at higher frequency, time taken from electrons from cathode is comparable to the signal being get amplified, and the noise arises because of that is called as transit time noise, right? And this increases with frequency at the rate of 6 dB octaves for tubes. And there are other noises called as miscellaneous noise, where we call it as partition noises, that is the multi-grid tubes. We can also call this as partition noise, that is multi-grid tubes contain more than one grid, and the partition of electrons from the cathode, right, among various grids will move in the random nature, and this creates noise, right? And that particular noise is called as partition noise. And this give rise to another source of noises in multi-grades, such as called as partition noise, right? And there is also another noise which is flicker noise, which arises due to the imperfections in the cathode surface of the electron tubes itself, or the surface of the semiconductors, and this happens at the low frequency range, right? And today what we have seen is, we have seen what are the different types of noises, what are the important characteristics of this type of noises. This is complete theory. I believe this video will be very useful for you. Thank you, my dear students.